welcome to my YouTube channel. Thanks very much for the subscription. For those who subscribed, those ones who have not yet subscribed, please do one thing: subscribe, put on a notification, and continue to learn. Today we are going to look at an important pathway, and that is the transforming growth factor beta pathway. This factor has a uniqueness from other factors. It has a tumor suppressive and a tumor supporting manner. This factor has receptors on the membranes, as we are going to see, and these ones form a heterotetrameric complex. What are the functions of the transforming growth factor? One is in tissue repair, where we see it inducing the fibroblasts to produce collagen. Another one is going to be in angiogenesis. Then another one is an anti-inflammatory effect. Then the other effect is the cell proliferative effects. This pathway is linked to the hallmarks of cancer, such as metastasis and insensitivity to growth inhibitors. What is the mechanism behind this effect? One mechanism is through the metalloproteinases, another one is through the mutations in tumor suppressor genes, and another mechanism is through sustained angiogenesis. What are the cancers that are related to this pathway? We have endometrial, stomach, and colon carcinomas. We have pancreatic carcinomas, and the pancreatic carcinoma is more related to the SMAD. What is SMAD? We are going to see what does SMAD stands for. Short forms that we are going to be finding in our pathway. We have COSMAD, which stands for costimulatory SMAD. Then RSMAD, which is receptor-regulated SMAD. ISMAD is inhibitory SMAD. Then SARA is SMAD anchoring for receptor action. Then SMAD itself is small mothers against decapentoplastic. You're seeing these digits 4, 2, 3, and 7. In COSMAD, we have SMAD4. We have different types of SMADs. And in COSMAD, we have SMAD4. In receptor-regulated SMAD, we have SMAD2, a complex of SMAD2 and SMAD3. And in inhibitory SMAD, we have SMAD7. Now, let us go to the pathway and we see what is going to be taking place here. We are having our cell membrane, as you see, with our receptors. What you're seeing here, this is the transforming growth factor beta receptor 2. What you're seeing in red is the transforming growth. When our ligand, that is the transforming growth factor, binds to the receptor, which is transforming growth factor beta receptor 2, this binding of the ligand to the receptor is going to lead to what we call dimerization of the receptors. We are going to have transforming growth factor beta receptor 1 coming in. Once it comes in, we are going to have autophosphorylation of the receptors, and this is going to lead to phosphorylation. It's going to lead to phosphorylation of our receptor-regulated SMAD. So this is going to phosphorylate our receptor-regulated SMAD. Once this one is phosphorylated, it's going to complex with costimulatory SMAD. So these two are going to form a complex. So this complex is going to be COSMAD, which we saw as SMAD4, then receptor-regulated SMAD, which is SMAD2 and SMAD3. So once this complex is formed, this complex is going to translocate into the nucleus. So it's going to translocate into the nucleus, and it's going to bind to our transcriptional DNA, and it's going to trigger transcription. So we have COSMAD and receptor-regulated SMAD, binding on a DNA, and we are going to see the end result is going to be transcription of target genes. So this one is going to be transcription of target genes.